Right, you're joining with the 2022 Inorganic Structured Essay discussion. Here, you need to know some deep points regarding inorganic. I'll teach you them. So here, the first one, this contains part A, which has three Roman numbers, and then you have the part B. So not much hard if you know your stuff very well. So let's say A is an ionic compound composed of three elements in the ratio 1:4:1, not in the order, right? One of these is a D block element that belongs to the fourth period of the periodic table. So that means it's one of the D block elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So out of them, one. Right? So when A is subjected to the flame test, lilac color is obtained. So lilac it should be potassium, right? Okay. On dissolving A in water, purple color solution is obtained. So what is the only thing which is dissolved in water and gives a purple color? MnO4 minus, right? And this ratio will satisfy that, right? So this will be like manganese, this will be like oxygen, and this is potassium, right? A is an ionic compound. Right, sorry about that interruption. Right, so manganese is 1, oxygen 4, and potassium is 1. So you have KMnO4, that is what they're talking about. So A is going to be KMnO4, so I'm going to write here KMnO4. So B is also another ionic compound composed of same three elements, and B dissolves in water to give a green color solution. That's going to be MnO4 2 minus. So actually that is K2MnO4, right? K2MnO4. So next one, C. C is a viscous colorless liquid. What are the two viscous liquids in the syllabus? HNO3 and H2SO4. Sorry, HNO3 and H2O2, not H2SO4, H2O2. These are the two viscous liquids in the syllabus. So make sure you write this in special notes or somewhere. I have taught this in the class. So here, composed of two elements. So only two elements are there. So of course it should be H2O2. We can understand that even by reading the first sentence. It disproportionates to give another solution, colorless liquid D as one of the products. C can act as oxidizing agent as well as reducing agent. So it perfectly fits with H2O2. When C is added to solution of B brown precipitate, that brown precipitate is MnO2 actually. MnO2 is formed. That's a black brown color precipitate. MnO2 that is formed after reacting with MnO4 minus and H2O2. It will form MnO2. So there you go. C is going to be H2O2. C is H2O2 and E is going to be MnO2. Right? E is going to be MnO2. Right. Its disproportion is to give a colorless liquid D. Colorless liquid is H2O. Right, H2O and as one of the products. C can act as oxidizing agent and reducing agent. Okay, right. So F is a compound composed of three elements. One of these three elements is a 3D element found in hematite. Hematite is Fe2O3. You have to know this in order to understand what is Fe. When barium chloride is added to a solution, white precipitate G that is insoluble in dilutation. Every year they are asking this. I have told you in before videos also. Every year they are going to ask you these things. So it's going to be barium sulfate that is formed, right? So of course it should be a sulfate here. F contains a sulfate and F contains Fe3 plus, right? Fe3 plus and a sulfate. So it's going to be FeSO4. Fe actually Fe3SO4 too. Right, there you go. Sorry, other way around. Fe2 SO4 3. There you go. Now here you might be wondering like why can't it be FeSO4? Why can't this be FeSO4 and why is it Fe? Now Fe2 plus Fe3 plus, they have not mentioned anything, right? So Fe is a compound composed of three elements. One of these elements is a 3D element found in hematite. So one of these elements, they don't say the oxidation number there. So it's Fe there, Fe is there. And these statements tell you that there's sulfate there, right? Disulfate, the SO4 minus is there. So either it should be Fe2 plus its sulfate or Fe3 plus its sulfate. We'll leave it like that for a second. Okay. Right. We'll leave it like that for a second. It should be FeSO4 or Fe2SO4 3. Hurry. It's either plus 2 oxidation state or plus 3 oxidation state. I'm going to leave it like that. Then look at the G. White precipitate G is barium sulfate. And H is going to be the next one. H is composed of three elements. When aqueous solution of H in a test tube is treated with saturated solution of F. Okay. Uh, of a small volume of concentrated H2SO4 slowly along the wall of the test tube, a brown coloration is seen on the surface where the liquids meet. The species responsible for the brown coloration is I. Brown fumes are not evolved when dilute H2SO4 is added to H when H is subjected to flame. Now this one. This is the brown ring test. Brown ring test is for Fe2 plus. Right? Brown ring test is for Fe2 plus. We are doing it to identify nitrites and nitrates with FeSO4. You need freshly prepared FeSO4 and you need H2SO4. Right? These are the things needed for the brown ring test. So H2SO4, any acid, a strong acid you need. So here, then this should not be Fe3 plus, right? This should be definitely Fe2 plus. So we can go with FeSO4. We are using Fe2 plus there. Right? So FeSO4 is needed. When aqueous solution of H in the test tube is treated with saturated solution of F, right? FeSO4, followed by addition of small volume of concentrated H2SO4, brown coloration is seen on the surface where the liquids meet. So that's a brown ring, right? The species responsible for the brown coloration is I, right? You need to know the compound, right? I had told you this in the class FeNO2 plus, right? This is the reason for the brown coloration. So brown fumes are not evolved and dilute H2SO4 is added to H. So dilute H2SO4 added, brown color gas is not evolved. So it can't be nitrate. It should definitely be nitrite. Sorry, not evolved. Sorry, my bad. Not evolved. Not evolved can, it should be nitrate, not nitrite. Because nitrite, when you add dilute H plus, brown color gas called NO2 is evolved. So they are saying not evolved. Not evolved can, you can eliminate that, right? So H is going to be composed of three elements. So H contains NO3 minus. Okay, it contains NO3 minus. When it's subjected to flame test, a yellow coloration is observed. So it's going to be sodium nitrate, NaNO3, right? It's going to be NaNO3, right? Then the next one, J. J is a sodium salt of a weak dibasic acid. On treatment of a solution of J with calcium chloride, the white precipitate K is formed. It's sodium salt of a weak dibasic acid. On treatment of a solution of J with calcium chloride, a white precipitate K is obtained. K reacts with dilute H2SO4 to give a weak dibasic acid and L as a product. A warm solution of J. Now, what is J now? J we have to identify, right? K also we have to identify and L also we have to identify. A warm solution of J acidified with dilute H2SO4 decolorizes an aqueous solution of A. Right. We have to find something that is reacting with MnO4 minus. Right, that is reacting with MnO4 minus. What I get to my head is oxalate. Right, so oxalate can be added here. So J is going to be sodium oxalate, Na2C2O4, and white precipitate K, that's calcium oxalate, which is insoluble in water. The solubility of calcium 2 plus ions with oxalate, I have discussed this. So it's insoluble, right? It's insoluble. And L is going to be a weak dibasic acid, that's H2C2O4, right? H2C2O4, and there you go. Those are the compounds you need to identify. Right, we are moving on to the second Roman number. Give balanced chemical equations for the following. Physical states are not required. Formation of D from C. Formation of D from C, that's the dissociation reaction actually. H2O2 dissociation, very easy. I'm not going to balance the reactions. You can balance them. I'm just going to write the reaction here. H2 and O2. Formation of I. Right, formation of I. So that's going to be the reaction in between nitrate, right? Nitrate and Fe2 plus joining together to form Fe3 plus and NO, right? So now it's about balancing the reaction using acidic medium. The reaction is happening in acidic medium because H plus is added. So this is going to be 3 into 2, 6, minus 6 plus 6 and plus 5. This is plus 2. This is plus 3. This is plus 2. So this one and this one, you subtract, you get 3. This one and this one, you'll get 1. So 1 into 3. So it's going to be 3 Fe2 plus 3 Fe3 plus. And now you add acidic medium. Now left hand side total charge 3 into 2, 6 and plus 5. Right hand side total charge plus 9. So that's going to be 4H plus to the left hand side. To the right hand side, you need to add 2 water molecules then. 2H2O. Now H plus means H2SO4, right? So you can leave the reaction like this. You can leave the reaction like this. And then what will happen next? Now this is not all. This is not all. Now I'm gonna condense this. This is not all. There's another reaction happening. After this reaction happens, Fe3 plus is gonna combine. Sorry, Fe3 plus. Fe2 plus is gonna combine with NO to form FeNO2. So this reaction I have given you under the brown ring test. I hope you can remember. So this is the formation of the brown coloration. Formation of K, right? K is going to be calcium oxalate, right? Formation of calcium oxalate, that is EC. Calcium chloride reacting with sodium oxalate, Na2C2O4 to form calcium oxalate and then 2NaCl. Now this is the thing. Some students are going with calcium sulfite. So that also can be taken as correct. Actually, that also validates all the statements given. Calcium sulfite will also react with MnO4 minus. So keep that in your mind. You can take sulfite also. If you have put sulfite, then that's also correct. You can consider that. Then next one, third one, an acidified solution of C. So when A is reacted with C, A reacted with C is MnO4 minus reacting with H2O2. H2O2, you can write the reaction actually. So MnO4 minus is undergoing reduction, Me2 plus, and then H2O2 is undergoing oxidation to form O2. You can write that reaction and balance it. It's just redox reactions. So you can manage with that. Then next one, aqueous solution of F with dilute H2SO4. F is going to be Fe2 plus. Fe2 plus reacting with MnO4 minus. That's very easy. It will go to Mn2 plus and Fe3 plus. Acidified solution of J. So J is C2O42 minus. So C2O42 minus reacting with MnO4 minus. It will go to carbon dioxide. This one will go to carbon dioxide actually. And MnO4 minus will go to Mn2 plus. So you can balance this reaction also. Balancing is not inorganic actually. It's chemical calculation. So you can manage it that. Then after that, the part B. Give the balanced chemical equations for the reactions taking place. State the function, oxidizing or reducing agent of H2S and SO2 in the reactions. Okay. First one, magnesium reacting with H2S. So this reaction you have, you know this actually. Write the balanced chemical equation to balance the reactions also. H2S, it will go to magnesium sulfide and H2 gas. Yes. So H2S here is undergoing reduction and it's oxidizing magnesium. So you can write acting as an oxidizing agent. Then magnesium and SO2, magnesium plus SO2 will form magnesium oxide plus sulfur, right? Magnesium oxide and sulfur. So here this reaction, SO2 will act as oxidizing agent. Right? Magnesium will act as an oxidizing agent. SO2 will act as an oxidizing agent. Remember that. Then next one, H2S and SO2. This reaction I have told you, it will form sulfur and H2O. Right? It will form sulfur and H2O. So that one, H2S will undergo oxidation. So it will be the reducing agent. And SO2 will be undergoing oxidation. Reduction, and it'll be the oxidizing agent. Then fourth one, sulfur and concentrated HNO3. So sulfur will undergo complete oxidation to H2SO4. Sulfur HNO3, it will go to H2SO4 plus NO2. So balancing this reaction, to balance these reactions, so this is a redox reaction. You have to balance using what you call, in the acidic medium, you have to balance this. H2O is formed. H2O is formed, right? H2O is formed. So there I go, right? So here they haven't asked anything. Who is what is the role of the compound? They haven't asked. So that is that. So this is the 2022 inorganic structure essay question. Little bit difficult here and all. You can take sulfite also. So yeah. And we had a problem where whether this is Fe2 plus or Fe3 plus. So we solved that matter by the next statement, right? With the next one, we can identify that because they are using the Brown ring test. For the Brown ring test, you need only FeSO4 and an acid and NO3 minus or NO2 minus. Both actually work. NO2 minus and NO3 minus both will work for Brown ring test. So yeah, see you again in the next video.